Hello, welcome back to learning computer applications and architectural design. This video is going to address the topic of using curves to generate surfaces, specifically looking at the extrude command. So we're going to start by looking at extruding open curves versus closed curves. So over here in my layers, I've got some curve layers and a surface layer and some point layers. For the purpose of this demonstration, I'll sort of be working between these two. So let's generate a curve. This is going to be an open curve. And let's generate a closed curve here. Okay. So the first thing is in extruding, you select the curve you want to extrude and you type in the word extrude curve. Now what this does is it allows you to extrude a surface from a curve at a given distance and at a given direction. So if we take a look at the drop-down menu that appears, direction enables us to change that's the standard Z, which is perpendicular to your construction plane, but you can also change it to other directions, such as this. And let's just do that again to show a typical, so extrude curve can go straight up. And let's give it 4. What's really nice about this is that you can extrude multiple curves very quickly and give them surfaces. Let's take a look at extruding closed curves. So we type the same commands in again, and we can type in a distance. Let's take a moment to look at what both sides does. If you select both sides when you extrude, it goes both the positive and the negative values for a given domain. You can also say whether or not it's a solid. So here I say if it's not a solid, it's just the curve itself which is extruding. Or if you do select solid, then it tries to cap your planar curve. So this is really good for generating sort of solid forms. You can also extrude it to a boundary. So here, let's create a boundary surface for it. So in this case, I'm now in my elevation, and let's sort of give a, okay. So now if I go type in extrude curve, and I select my base, I'm going to say extrude to boundary, and then it asks me which is my bounding surface, and I select my surface I generated, and now I can remove this guy, and it extrudes based on the profile of that surface. This also can work with, let's put everything here, select surfaces, change object layer, and let's move these over here, change object layer. So in these cases, we've seen extruding an open curve, we've seen extruding a closed curve as a solid or with both sides, and we've looked at extruding a curve to a surface. Let's take a quick moment to look at how you can use this to affect multiple curves. So in this case, let's make a series of, we'll make a closed polygon shape, and we will array it about like this. Okay. So here's my set of arrays. Now I can select my curves, make sure they're on my curve layer. Now I type extrude curve, and it will extrude multiple curves. In this case, let's see what it looks like if we give it an interesting surface to extrude to. So in this case, what I'm doing is I'm generating sort of two types of curves. And I'm going to extend some of the language we used last time, which is had a loft. So let's do loft between this curve and this curve and go OK. Here's my loft options. Let's do not simplify. Perfect. And now let's look at extruding these. So we're going to select our curves. And then deselect our, we only want to select the curves that we want to extrude. Now let's extrude these curves to a boundary. Select the boundary curve we just generated. Okay. So what we also see is that some of our curves were not completely caught. So it has to be totally totally captured by the bounds of the surface. So let's scale this surface a bit. One-dimensional. We're going to go from the middle. Let's make sure we have midpoint on. And let's just sort of give it a bit of breathing room. Okay. So let's select our curves we want to extrude. And this time, let's extrude to a bounding surface. Great. And we can remove this. And here we see each one of those original curves extruded to a bounding surface. Let's open up Grasshopper and see how it works in there. So let me remove these. Let's type in the word curves. Let's assign this container to all of our curves here and say OK. Now, similar to how it works in the Rhino environment, all that's really required is a direction. So in this case, let's say a Z. And a curve. So there's our base curves, our direction, and how far do we want to have these extrude to. Now, what's really good about Rhino, of course, is being able to sort of control different elements. So in this case, let's see if we can give some unique vectors to these curves. So they sort of, let's have them follow this curve here. So what I mean is I want the heights that they're extruded to depend upon the curvature of this curve. So why don't we type in curve? Let's bring this into Rhino, or Grasshopper, excuse me. Set one curve there. Okay. And we need to make sure that there's the same number of unique elements as there are divisions in the curve. So for this, let's do divide. We're going to divide this curve by 99. Okay. And now what we want to do is evaluate the normal at each of these. So what we can say is, okay, so there's my normal, and it comes in as a vector. And so what I want to do is I want to deconstruct this vector, and I want to take this y value. Let's use the multiplication sign here. And let's see, so we have our y's here. So if we multiply this by 10, and we plug that in, we should get some of these extrusion heights that are based on that y value. So here now we can see those extrusion distances responding to the curvature as measured in the y. So let's just change the scale a little bit and sort of get it in the right spot. And you'll also notice that some go up and some go down. This is because there's an inflection point in the curve, which means that it will switch directions, meaning it will become negative. It will take on a negative rate. So this is an example of using sort of associative geometry in extruding multiple elements. Now, you can use a variety of strategies of associating sort of values to extrusions, but I hope that you found this useful. Okay, great. Thank you.